All right. Good afternoon, everybody. Still afternoon, but I decided to do a couple of things other than the roguelike celebration. We had a longer episode. I suspect probably it's going to be the case that I need to break up the parts in individual videos. I think probably the setup was going to be something that was more straightforward, and I realistically will probably only be able to get through one part at a time. But I did want to deal with some of the material that I sort of left to think about while I was working between or while I was between videos. One of them is actually quite straightforward. So we had, I think it was in engine. So to do why can't I use a switch on this? Well, right now, without me really paying attention, this is actually completely changed. In this case, it's really not appropriate to worry about a the case matching. But I did think about it a little bit. So this is one of the things that can be a drawback for doing a video, or I mean, I'm not doing this live, but essentially doing something that's not going to be edited after the fact. You can get sort of stuck in a rut, and then as soon as you sort of step away from the keys or you do something else, the idea is pretty clear. So pattern matching is not the same as the if else, right? So if and else is going to be based on a Boolean value, right? So either this thing is true or it isn't. And the pattern matching is already doing those comparisons. And we saw that in the tutorial, right? Where it says that it will use the double equals unless it is, I think it's a Boolean value or a, what was it? It was a Boolean value or none, I think. And in that case, it uses is. So what I think was happening here, I can't fully explain everything that was going on in terms of the different classes, and I think it was saying, like, it was looking for an instance of something. I can't remember 100% what the problem was, but essentially what I was doing is I was treating them as perfectly equivalent, and what I probably should have tried would have been to use this is sort of the top of the match, right? So the dispatch event is fine, but what I should have been doing is I should have been making the match the class itself. Now, I still don't 100% know if this would have worked. So like I'll try and give an example here. So something like match event handler dispatch event, and then we would do case and then something like that. Of course, movement action isn't this shouldn't be assigned but never used. Okay, now I'm really confused because this shouldn't exist in this context. So the thing that's not clear to me, whether or not this would work, is we have is instance. So is instance, I think, is different from doing, right? So essentially what we're sort of saying is that we're sort of unpacking, then this would be like an if instead. But essentially we're trying to say whether or not these things are true. And I believe there is a difference between is instance and the double equals. I think that's why is instance exists. So, I'll say this is like a partial complete on that particular question. In one sense, so it's mooted by what's happened to the program. But I think it's also clear that my understanding of the pattern matching isn't quite perfect yet, because I have this case where it's like, well, this seems like it would be helpful, but because I'm trying to determine whether or not something is an instance of another, I don't know whether or not the pattern matching would apply here. And then, but the other thing that's nice about this is I have a little bit of a path to follow, right? I have an experiment that I could run now. I can open up a different Python session and play around with some classes and see whether or not I can get an equivalent to the cases. But again, it's just, I think I even said it at the time, right? This is the hammer that's going to turn everything into a nail. I wasn't able to get it to work. And I had a question, okay, so why am I struggling with this thing here? And in this particular case, it was because I was treating case as equivalent to an if, and it's not. It's actually doing the comparison. So case is, basically case is instance such and such. I'm comparing the result of is instance to self event handler dispatch, and this shouldn't be equal, but we didn't even get to that point. The program had other problems. Now, again, this is going to be partial credit day, I think. So another one that I had some questions about was the annotations future. And this one I couldn't get a straight answer on. So if we do Python, so I think the idea here, so from future import annotations was previously scheduled to become mandatory in Python 3.10, but the Python Steering Council twice decided to delay the change. Announcement for 3.10 and announcement for 3.11. No final decision has been made yet. See also PEP 563 and 649. Now, I don't know this future, I really don't know this future module as well as I should. So I don't know if the idea here is that this is optional and mandatory for inclusion in the future module. I don't know if this is an indication in terms of, what's going to be added to the language. I do note that nothing really seems to break if I comment this out, right? So we can just run that here. Oh, maybe it does. Well, that's interesting, actually. So I guess I answered my question here. Yep. So I wish I had a better theoretical reason for saying this. I think I just didn't save the change to entity when I was playing, or to actions when I was playing around. I suppose that answers my question, but this has definitely taught me that I need to understand this a little bit better. And again, when it says mandatory, I'm not 100% sure if this is saying that it's mandatory as part of Python or if it's mandatory as part of the future module. But it's fairly clear here that there's some kind of interaction between annotations and engine, which is causing a problem. Sorry, that's actually right here. And I think what it might, I'm trying to recall exactly how this goes, but I think there was something about the order in which things get evaluated is what's being played around with inside the annotations. Again, typing is something that I don't really interact with in Python. It is something I am warming to, and it's something that I think has been helpful for this project here, but I clearly don't know it well enough to be able to sort of predict behavior on the part of the program. And then I obviously need it here. But it did sort of indicate to me that I probably want to understand this future module a little bit better. But the actual question that I had at the time, which was, is this necessary? Has the development of Python brought us to a point where I can say this is now part of the language? Not with certainty, let's say, but I think it would be fair to say that given that there's a TBD attached to this, even with the arrival of 3.10, maybe based on the reading down below here, Maybe had the world turned out a bit differently, this would have been fine to remove, but in this case, it isn't, so I'm not. All right, so that's it for the standard library. I was also going to be messing around with rough a little bit. I didn't really bother with that just because at the moment here, I've just got bigger problems. I would like to spend some time learning it, but in this case, it didn't really seem necessary for part of this project. One other thing, which is not really relevant to this video, but I might as well just get it out of the way now. I did actually upload a couple of videos on the YouTube channel already. So this one I'm recording as the other two have been put on. I think everybody's going to kind of get blasted by these right away at the start, and then probably there'll be one or two a week that come up, assuming that I can kind of keep the pace that I've been doing so far. All right, so let's move to the next part of the tutorial. Part 3, generating a dungeon. Note, this part of the tutorial relies on TCOD version 11.14 or higher. You might need to upgrade the library and your requirements.txt file if you are using one. So we do have a requirements file, but we're using TCOD 16.2.3, so well above what we need. Remember how we created a wall in the last part? We won't need that anymore. Additionally, our dungeon generator will start by filling the entire map with wall tiles and carving out rooms so we can modify our game map class to fill in walls instead of floors. And actually, I think what I'm going to do here is I'll keep main open, but I'm going to just close the remaining windows so we can have a little bit more of a tidy space. So we will adjust self-tile. So in this case here, I just think we're going from floor to wall as it said. So that's an easy change. And then we don't need to add the test wall. So that's that. Now on to our dungeon generator. I mean, if we want to test and make sure everything's running. Oh, that's interesting. I seem to have messed up my... Wait a minute. Right. There's a reason I can't. I haven't messed up the movement. I have, however, just encased my character into a wall. That's why I can't do that. So let's not go changing anything. Probably why it told me not, or didn't tell me to play the game. The original version of this tutorial put all the dungeon generation in the game map class. In fact, this was my plan for this tutorial as well, but as Hexadecimal, author of the TCOD library, pointed out in a pull request, that's not very extensible. It puts lots of code in the game map where it doesn't necessarily belong, and the class will grow to huge proportions if you ever decide to add an alternate dungeon generator. As an aside here, this is the same Hexadecimal who is actually participating in this, so I believe you'll be able to follow their progress through this GitHub repo. I'm not really following the other repos as part of this just because I want to try and develop my ability to work out problems for myself and see if I really follow what's going on. But I can see myself in a future year, trying to do something that's a little bit, a little bit more outside the box. Okay. So it puts a lot of code in game map where it doesn't necessarily belong, and the class will grow to huge proportions if you ever decide to add an alternate dungeon generator. The better approach is to put our new code in a separate file and utilize game map there. Let's create a new file called procgen.py, which will house our new procedural generator. Whoops. Right, our old friend init. So as we've sort of seen from a few other examples of this, we kind of already get an idea about how a rectangular room is going to be defined, right? Presumably an x-coordinate and y-coordinate either is going to be a center, an origin. For consistency with the rest of the scheme, I would assume that probably the x and y is maybe the top left corner of the room, and then we get a width and a height. So that's just going to give us an idea of the dimensions, and then everything from that is going to, these are just values to work with, but presumably there's going to be some code that will build out the room based on those specifications. So x1 is x, x2 is, oops, y. Okay, that seems to be consistent with what we just said. Now this is a decorator. Decorators I kind of understand and kind of don't. So I'm going to leave the tutorial to say what this does, because it really does change in terms of specifically what these are. So one example I've seen in terms of using decorators would be, there's sort of a, I think this is like a basic thing that you'll wind up doing in most kind of learning, but the Fibonacci sequence, right? The one that is the series of numbers where after you define the first two, 1 and 1, you can get each subsequent number by adding the preceding two numbers. So 1, 1, 2, 3, 5, so on and so forth. And one way you can learn recursion is to get someone to do a Fibonacci function, right? It's just sort of, does someone know that you can sort of feed the function into itself? And maybe in some cases, does this person know that this is actually something you can do in that programming language? Because I don't believe you can do this in every language. But I don't know. It's a really, I think it's a really straightforward and really simple one. But it's actually one that doesn't always. It's one where you can actually get into a bit of trouble. And so depending on what people are testing, they may want something that is a better implementation. Because if you think of it, once you start getting sufficiently far into the Fibonacci's and you're calculating each number by running that program over and over again, you're doing lots and lots of calculations. Like the number of times that you calculate 3, if you want to try and get to the 10,000th Fibonacci number, is enormous. And it's one where very quickly, once you start trying to get to higher and higher numbers, it just takes too long. Even if you've got a very good computer, just the sheer amount of calculation is going to take even a good computer too much time to go through. And this is one of these examples where there's actually a lot of low-hanging fruit to work with, because really, in terms of calculating those Fibonacci numbers, you really just need to calculate them once, and then you can keep reusing them. And so there's a decorator in Python. In fact, even if you don't want to get clever, because there's a number of different ways that you can actually calculate Fibonacci numbers. In fact, there's a math textbook that I quite like, Linear Algebra Done Right, and one of the covers for it, there's 4 editions, so it depends on which one you're looking at. But I think the most recent edition actually has a formula for calculating Fibonacci numbers. And that's going to be faster than any recursive one, because in that case, you just plug the numbers in and you're ready to go. But one way that you can get a big speed up in terms of Python is there's a decorator that will actually keep the old calculations. It'll sort of cache them in the background. So that way, instead of having to recalculate a set of numbers, you're able to sort of decide how far down the chain you want to go and keep those, so that if you do have these really repetitive calculations, you only do them once, and then you're just simply referring to the values. And then, of course, if you're being tested on algorithms or something like that, chances are they're not going to let you use that decorator. I mean, I'm sure they'll be happy to know that you know about that, because it shows that you've gone a little bit further than just looking at the surface level tests. I'm sure there are people who coach you on sort of common programming questions. But presumably, if somebody's really trying to see, whether or not you can think your way through a tricky problem like that, what they're going to want to see is, are you able to realize those benefits without using a decorator or something like that? And probably at that point, they'd put you in front of something that's not Python. But anyways, I've never done those kinds of interviews, so I'm really guessing here, and it's not important to what we're talking about right now. So I am interested in seeing what property does. Again, it's going to be different from, actually you can probably say, can be used to define a managed attribute X. Decorators make defining new properties or modifying existing ones easy. So is this just, adding X's and Y's? So if I were to do property, that can't be right. Maybe it is. We'll see what it says in terms of the documentation, but it may actually just be that it's adding something like well, no, because then they'd be calling them attributes rather than properties. Anyways, let's not speculate. Let's just implement it and see where this goes. So def center. You can probably already guess what the program looks like. Take the certain values and divide them by half. So it's going to be a tuple with 2 integers, presumably the x and y coordinate. I'm bad at doing the double. This actually kind of interests me. So I always manually made the tuple. So normally I would do something like this. I've never tried to return two arguments in Python. So again, I learned something. Okay, inner. So this just takes itself. It returns 2 slices of a tuple. I'm very interested in seeing what a slice is. Sorry, 2 slices of a tuple doesn't make sense. 2 slices contained in a tuple. Oh, interesting. So I think most people are probably going to be familiar with the idea of a slice. So if we have to, and then if I were to take a slice here of, let's say, 1, 2, 3. So this is 0. So 1, 2, and then I guess 3 wouldn't be included. So it would just be 2. We can run this in a Python session, actually, but sorry, just give me a second. Excuse me. So I guess that's a function to produce that. Let's just double check that my understanding is correct. Yeah, so 2 and 3. So I guess if I were to take actually, that doesn't quite make sense because there's no, well, let's, oh dear, what button did I hit? Let's just quit. Cool. So if I do 1 through 9, so this will get me my 1 through 10, and we do 1, 3. Okay. So if I do slice 1, 3, is that the same thing? It is. Why is it giving me 2, 4 though? There we go. Right, because the range is, yeah, I know why. Okay. Sorry, I'm purely experimenting in here, but I get it. So essentially what this is doing here is this is defining this little thing here. And when it says return the inner area of this room as a 2D array index, essentially it's saying it's like, okay, do you want to know the room part of the room, right? So if I'm trying to put furniture inside of my apartment building, I am going to want to care about the parts of the room which have, which I can put furniture in. If I have got, 10 feet wide concrete walls around me, number one, that would be wonderful. And I'm not going to have to hear my upstairs neighbors and their presumably the elephant that they have bought. But number two, the dimensions will matter quite a bit, right? 10 feet is a fairly large number to be off by. So maybe I will not get the king size bed. All right, so I think I have a fairly good idea in terms of what this does, save for the idea of the property, which presumably we're going to be finding out in a minute. So the init function takes the x and y coordinates of the top left corner and computes the bottom right corner based on the width and height parameters. Center is a property which essentially acts like a read-only variable for our rectangular room class. It describes the x and y coordinates of the center of a room and will be useful later on. The inner property returns two slices, which represent the inner portion of our room. This is the part that we'll be digging out for our room in our dungeon generator. It gives us an easy way to get the area to carve out, which we'll demonstrate soon. We'll be adding more to this class shortly, but to get started, that's all that we need. What's with the +1 on self x1 and self y1? Well, this I already know because you don't include the last number in terms of the inner, and then you would include the first number, so you can't actually include the wall. I think we kind of talked about that, but let's see their explanation. What's with the +1 on self x1 and self y1? Think about what you're saying when we tell our program that we want a room at coordinates 1, 1 that goes to 6, 6. You might assume that that would carve out a room like this one. Remember that lists are 0 indexed, so 0, 0 is a wall in this case. That's all fine and good, but what happens when you put a room right next to it? Let's say that the room starts at 7, 1 and goes to 9, 6. There's no wall separating the two. That means if the two rooms are one right next to the other, then there won't be a wall between them. So long story short, our function needs to take the walls into account when digging out a room. So if we have a rectangle with coordinates x1, 1, x2, 6, y1, 1, and y2, 6, then the room should actually look like this. This ensures that we will always have at least one tile wide wall between our rooms unless we choose to create overlapping rooms. In order to accomplish this, we add +1 to x1 and y1. One other thing that I'll just say here, so my understanding here is that the properties, I guess, are like this. It is interesting that they're fixed. So I guess in this case here, we wouldn't have moving rooms. We presumably also couldn't have, say, the collapsing of walls, which would change the inner area. These are just things I'm sort of imagining, right? So what do these choices prevent for us? But again, I'm still getting a bit of a read on a priority on property. That might be something that I read after doing the tutorial. Before we dive into a truly procedurally generated dungeon, let's begin with a simple map that consists of two rooms connected by a tunnel. We can create a new function to create our dungeon, intuitively named GenerateDungeon, which will return a game map. As arguments, it will take the needed width and height to create a game. Let me just try reading that. Sorry, my microphone stand was kind of in the way of reading that. So let's see if we can get a clearer read on that. Before we dive into a truly procedurally generated dungeon, let's begin with a simple map that consists of two rooms connected by a tunnel. We can then create a new function to create our dungeon, intuitively named GenerateDungeon, which will return a game map. As arguments, it will take the needed width and height to create the game map, and it will utilize the rectangular room class to create the needed rooms. Here's what that will look like. So from game map, import game map. Import tile types. So we've already got the rectangular room, but we're now going to add generate dungeon. So just hard coding a 20 and 15 in there. This is the 2 temporary rooms it's talking about. Oh, you know what? I forgot to double check how the movable works. That's a thing. I'm sorry, just give me a second here. I'm actually going to make a note for myself. I was a little confused in terms of how the indexing worked on one of the maps in the previous video. That was something that I forgot to follow up on because I didn't write a note inside the game, but I'm not going to waste time on that right now. Okay, so as it said here, we're going to carve out the rooms. So we have all walls, and we're now converting these into floors. Oops. All right, now we can modify main.py to utilize our new generate dungeon function. Okay, we're not importing a game map, we're generating one. The game map is now getting generated. I'm inclined to agree with the reasoning. I'm inclined to agree with the feedback for this one. I think the idea of having a generate dungeon function makes a lot of sense. All right, now is a good time to run your code and make sure that everything works as expected. The changes we've made puts 2 sample rooms on the map with our player in one of them. Our poor NPC is stuck in a wall though. Nyuk, nyuk, nyuk. I'm sure you've noticed already, but the rooms are not connected. What's the use of creating a dungeon if we're stuck in one room? Not to worry, let's write some code to generate tunnels from one room to another, adding the following function to procgen.py. So it looks like we are removing the 2... Oh, no, we're adding... Should probably know better than say that we're removing things. We're always adding in. And okay. So after the return slice, so this is generate dungeon. Before generate dungeon, we are defining tunnel between. So this returns an iterator. I think that's because tcod produces one. Something's wrong. Okay, so tunnel between. The start is presumably an x and y coordinate. The end is presumably an x and y coordinate. We've got the close parentheses here. The result should be an iterator of tuples with x and y coordinates. And what weirds me out here is I should hit enter, and then this should already start me off tabbed, but it doesn't for some reason. So I'm thinking there may be an error that emerges at some point. But let's just see. Turn an L-shaped tunnel between these 2 points. date start point endpoint, random less than 0.5. Presumably this is just so that all the L shapes aren't in the same direction. I have no idea what Bresenham is, but return a thin Bresenham line as a NumPy array of shape length 2. That's going to be a Wikipedia search, I think. And then it's going to turn this into a list. So this is the iterator that it was promising. This is also a neat one. So you've got yield XY. So this is a feature that I loved as soon as I learned about this in Python. So you can have lists of things, but you can also make generators. So imagine that you had a list of phone numbers. Let's just say it's like a phone number for everyone in the world, or an identification number, because obviously not everybody has phones. And I mean, we all have like amazingly good computers now. So even this is probably a little silly, but like, let's just say that, you know, you had a bunch of, actually, no, here's maybe an example. Let's say on top of that, maybe it wasn't just numbers. Let's just say that for every individual in the world, you had a database that had all the information that could be known about them. And that would also include, video, that would include photos, that would include, everything that can be found about these individuals is in this database. So something absolutely enormous, and then multiply that. Well, for some people, potentially enormous. And then, of course, multiply that over, 7 or 8 billion people. So you could imagine, and like, let's say that the thing that you needed to do here was actually just take a very simple piece of information from them. But for one reason or another, it needs to be, you need to do something that manipulates this big stack. You've got a class, and it's just this big super class that has all sorts of crazy stuff about this one person. And you know that you can process one person at any given time, but you do need something to handle all that information for that one person. And so if you try and bring 2 people in, you're done, right? But if you can do it one person at a time, you're good. So you can imagine, a list of people like that, but that's a non-starter, because now you've got, the world, which has to be kept inside of memory. But what you could do instead is you can take a generator, right? And in that case, the generator is going to give you the items each time you run into yield. So it's like, okay, I've got my big database, I want to get a name and a birthday or something like that. I don't care about the baby videos. I don't care about, the high school grades or something like that. But, I'm going to have to sift through all of that to make sure that I get the 2 bits of information that I want. In this case, a generator would help you out, that you're not going to have more than one person at any given time. What you're effectively giving the program or what you're giving the computer is basically an instruction for how to wind up making those things. So that range that you saw before, the range doesn't actually have all the numbers in memory. So for instance, if I did a list of 1 billion numbers, all those billion numbers is inside my computer at that time. If I give it a range of those exact same numbers, well, I mean, obviously, I can't say those same numbers because maybe I just pick random numbers, but the range is a generator. And so in that case, it will actually take up considerably less space I could probably actually show that by like bringing up the resource monitor and all of that. But anyways, I think these are really cool things. I always smile whenever I see a generator. So, and actually, so this is more than just sort of coming up with excuses not to type the details in. This is actually something that wound up helping me out at work one time, because we switched to some cloud instances where I think they didn't appreciate, like there's my job title, and then there's what I do as part of my job. So somebody looked at my title and assumed that I wasn't doing very heavy computation. And it was basically one of those questions of, okay, the deadline's coming up really soon. Oh, by the way, they've completely changed the way we do everything. And I can't actually generate what we need, right? They've blown up what we want, or it's going to take so long. Like, we can't afford to have a mistake. And we always know this takes like 1 or 2 tries to get right. So in that case, I was actually, it wasn't the only change, but basically there was a generator. There's a couple spots that naturally lent themselves to generators, and there's a couple of other tricks which kept the worst from happening. So that's why I think fondly of them. All right, let's dive into this method. Tunnel between. This function takes 2 arguments, both tuples consisting of 2 integers. It should return an iterator of a tuple of 2 ints. All the tuples will be x and y coordinates on the map. Return an L-shaped tunnel between those 2 points. We grab the coordinates out of the tuples, simple enough. We're randomly picking between 2 options, moving horizontally, then vertically, or the opposite. Based on what we've chosen, we'll set corner x and corner y values to different points, and then generating the tunnel. And as it says, this is the part where the magic happens. TCOD includes a function in its line of sight module to draw Bresenham lines. Bresenham's line algorithm is a Landran algorithm that determines the points of an n-dimensional raster that should be selected in order to form a close approximation to a straight line between 2 points. It is commonly used to draw line primitives in a bitmap image, e.g. on a computer screen, as it uses only integer addition, subtraction, and bit shifting, all of which are very cheap operations, inexpensive operations in historically common computer architectures. It is an incremental error algorithm and one of the earliest algorithms developed in the field of computer graphics. An extension to the original algorithm called the midpoint circle algorithm may be used for drawing circles. While algorithms such as Wu's algorithm are also frequently used in modern computer graphics because they can support anti-aliasing, Bresenham's line algorithm is still important because of its speed and simplicity. The algorithm is used in hardware such as plotters and in the graphics chips of modern graphics cards. It can also be found in many software graphics libraries. Because the algorithm is very simple, it is often implemented either in firmware or the graphics hardware of modern graphics cards. The label Bresenham is used today for a family of algorithms extending or modifying Bresenham's original algorithm. And this all looks very interesting, but I'm going to save that for my own reading. While we're not working with line of sight in this case, the function still proves useful to get a line from one point to another. In this case, we get one line, then another to create an L-shaped tunnel, list. Converts the points in the line into, as you might have already guessed, a list. What's with the yield lines, though? Yield expressions are an interesting part of Python, which allows you to return a generator. Essentially, rather than returning the values and exiting the function altogether, we return the values but keep the local state. This allows the function to pick up where it left off when called again, instead of starting from the beginning as most functions do. Why is this helpful? In the next section, we are going to iterate the x and y values that we receive from the tunnel between function to dig our tunnel. Let's put this code to use by drawing the tunnel to our 2 rooms. So, yep. X, Y, and tunnel between. Run the project and you'll see a horizontal tunnel that connects the 2 rooms. It's starting to come together. All right. Didn't like the to list. My bad. Didn't even say. This is why I like Python errors, though. I feel it's like we're just 2 versions away from it asking if you'd like a cup of tea when it tells you there's an error. Seem to be having a hard time. Maybe we get T in Python 3.15, and then they add the please statement in Python 3.16. Now that we've demonstrated that our room and tunnel functions work as intended, it's time to move on to an actual dungeon generation algorithm. Ours will be fairly simple. We'll place rooms one at a time, making sure they don't overlap, and connect them with tunnels. We'll want a method that tells us if our room is intersecting with another room. Enter the following into the rectangular room class. So need to add the future. That's interesting. So future gets its own line while random and typing don't. This is definitely something I need to learn about. Okay, after inner, this is not a property, intersects. So we pass it another rectangular room, it turns out a bool. This is also, so I'm not going to do this here just because, you know, there's some things that I think are worth taking some time to think about, but other ones, you know, it's maybe something that would be fun to do on your own time, but maybe isn't worth putting into a video. But one thing that would be kind of interesting in these cases, when you run into a method like intersects, this is one of these cases where, depending on the day, depending on how I'm feeling, I would probably be inclined to trying to see if I can figure this one out for myself, right? So we have a rectangular room. We know the coordinates. So we have the upper left and we have the width. And we also have the height. And so, you know, based on that information, how would you determine whether or not there was an overlap? And, you know, once you have that algorithm in mind, maybe the next step would be, okay, given what I know, is there a way I could improve this? Is there a way that I could make this a bit more efficient, right? Is there, if you're checking every single tile in the entire map, is there a way you could reduce it down to only the 2 rooms in question? Better still, you know, how do you make it so that as soon as you find one overlapping point, you know, you have the, once you find an overlapping point, you know, you just stop running the thing. These sorts of things. Again, you're not, you know, you're not discovering the inverse, was it the inverse square algorithm or something, the one that made, you know, I know they didn't originate it, but like there's the really famous one for id Software that just made stuff run really well. And it's just a crazy, weird thing that doesn't look like it should work, but it does. You know, like you're not getting that kind of an improvement out of it, but it's a good example of how, you know, you've demonstrated the work. You know, somebody had to sit down and figure this out for this tutorial. So can you get yourself to a point where you're solving these things on your own? Sometimes it's nice to ask yourself these kinds of questions, but in this case, self x1. So we take the origin, presumably, other x2. Greater than or equal to other x1. y2. So one thing that's nice about this one is that you've created 4 tests, but what's nice is that if this one fails, the way that AND is structured, it's not going to bother testing the other ones. Same way as that if this was ORs and this was true, it wouldn't evaluate the other ones. So that's kind of an example of what I was talking about before. Intersects checks if the room and another room, other in the arguments, intersect or not. It returns true if they do, false if they don't. We'll use this to determine if the two rooms are overlapping or not. We're going to need a few variables to set the maximum and minimum size of the rooms. Oh, excuse me. Along with the maximum number of rooms one floor can have. Add the following to main.py. So after map height, $30 max rooms. Interesting. I guess maybe I'm biased because the two rooms we had were somewhat large. At long last, it's time to modify generate dungeon to, well, generate our dungeon. You can completely remove our old implementation and replace it with the following. So we add type checking. So what do we have? We have iterator, list, tuple, type checking. Okay. Okay, we keep the dungeon. I think we'll just get rid of this. So list of rectangular rooms are in range max rooms. Randint. Basically, based off of these parameters, we're saying is like, okay, so we can up to the max. Actually, this is interesting. So this is going to make the maximum number of rooms no matter what. Okay, I'm interested in seeing where this goes. Okay, so this is presumably deciding where it starts. Okay. Okay, so if they intersect, we just don't add the room. But for some reason, rooms... Okay. So we have to have at least one room. Which would have already happened because there's no intersections. Okay, player starts in the center of the room. This is what stops us from getting trapped in a wall. Now this is interesting. So if it's going to dig out a tunnel between this room and a previous one, it's possible that there's two rooms that are on opposite sides of the map. I'm kind of interested in seeing how this turns out. X, Y, in tunnel between rooms -1. Right, so rooms -1 center. We know we have one room because length of rooms is 0. Actually, this is funny because if we did technically we could get by if not rooms. But that's not really clear. Although we already have a comment explaining what this is. Okay, so basically we already have a room. We're building another one. And what we do, because we're indexing at -1, we're saying the most recent thing added to the list. So in this case, or the thing at the end. So makes sense. We're tunneling to the center of the previous room. Tile type. Right, sorry, it's creating the parts to dig out between the rooms. All right. And return the dungeon. Quite a lengthy function. Let's break it down and figure out what's doing what. This is the definition of the function itself. We pass several arguments to it. Max rooms, the maximum number of rooms allowed in the dungeon. We'll use this to control our iteration. Minimum room size, the minimum size of one room. Room max size, maximum size of one room. We'll pick a random size between this and room min size for both the width and height of one room to carve out. Map width and map height, the width and height of the game map to create. This is no different than it was before. Player, the player entity. We need to know, we need this to know where to place the player. Generate a new dungeon map, dungeon game map. This isn't anything new. We're just creating the initial game map. Create a list of rectangular rooms. We'll keep this a running list of all rooms. For our in-range max rooms, we iterate from 0 to max rooms -1. Our algorithm may or may not place a room depending on if it intersects with another. So we won't know how many rooms we're going to end up with, but at least we'll know that number can't exceed a certain amount. So it is just worth mentioning, right? So if you run this enough times, and this is a very remote possibility, but if you run this enough times, it's possible that it only ever generates one room, because if you have, let's say, 30 rooms and then 29 intersections, those are all going to wind up canceled because they overlap. So you have a dungeon of one room, which would be wild, very fun. I wonder how many times stuff like this happens in No Man's Sky, but I'm obviously not losing any sleep over that. And presumably you can minimize the chances of something like that happening by choosing appropriate sizes for the rooms themselves. Here we get the minimum and maximum room sizes to set the room's width and height. Then we get a random pair of XY coordinates and try to place the room down. The coordinates must be between 0 and the map's width and height. We use these variables to then create an instance of our rectangular room. So what happens if the room does intersect with another? In that case, we toss it out by using the continue to skip the rest of the loop. Obviously, there are more elegant ways of dealing with a collision, but for our simplistic algorithm, we'll just pretend like it didn't happen and try to move to the next one. So this is where we're digging the room out. This is similar to what we were doing before to dig out the two connected rooms. We put our player down in the center of the first room we created. If this room isn't the first, we move on to the else statement. This is similar to how we dug out the tunnel before, except this time we are using a negative index with rooms to grab the previous room and connecting the new room to it. And regardless if it's the first room or not, we want to append it to the list so the next iteration can use it. So that is our generate dungeon function, but we're not quite finished yet. We need to modify the call we make to our function in main.py, presumably to add the player. Or, well, not just the player. We add all this other stuff that we added as well, but player is going to be a big one. Okay. And that's it. There's our functioning, albeit basic, dungeon generation algorithm. Run the project now, and you should be placed in a procedurally generated dungeon. Note that our NPC isn't being placed intelligently here, so it may not be stuck in a wall. Rectangular room does not have intersects. Where was that? Line 84. I wonder if I click on this, does it take me? No. Well, yeah, look at that. It's kind of interesting to see. So I've always wondered like what the deal would be if there was a path or like a room that just wound up sort of slicing through the wall, but it actually doesn't look that bad. It arguably looks a little more natural because like right now for so many of these, they're big blocks at the end of hallways, whereas having a nice sort of big open front, you know, it's certainly not like, actually, I think there's like, I think I've seen Elder Scrolls level like this, right? So there's the entrance to the castle and then you walk in and sort of there's the receiving room and then you go in and there's like the throne here and then maybe this is, you know, the way to the king's chambers or something like that. So again, I don't know how carefully thought through some of this stuff was, but it's actually kind of neat to see how some of these things that might be seen as imperfections actually do provide a little bit of character. So this is the point to me, and I think I actually really like, as far as the structure of this tutorial, I actually really like that this is where it is. This is the sort of thing that how do I put this? Like I've done in Pico 8 a variation of this more with like solar systems, and I absolutely implemented a button where like I'd push the button and I'd just make a new system. And like, this is always kind of fun, right? You get to see something new. So, you know, in this case, we'd close and then reopen and just kind of see all the different, I actually really like how that had two pathways into it. There's some really neat levels that seem to be coming out of these parameters. This is kind of neat. So yeah, here's a good example, right? Like this wasn't, I don't think this was ever intended, but we have these nice, like big, thick halls. You know, and that just happened to be, you know, the way that this map wound up generating. So these are kind of neat to look at. Oh, I should be paying attention to the future warnings. So your note your dungeon will look different from this one, so don't worry if it doesn't match the screenshot. So there will be one last thing to do. Relatively short episode given how the previous ones went, but I'm actually not feeling too sad about that because I do have other things that I need to do for the day. But I should be dealing with the future. So future warning, this attribute has been renamed to RGB. So that is in game map 16. Am I really allowed to do this? Whee. Well, it's not complaining about it, so there we go. A bit of a shorter but very pleasant little tutorial. So we'll commit, and this time we're going to sync because we've done all of our work for the day. And I will, so this was the last little bit of work that I needed to do to catch up with where RoguelikeDev does the complete roguelike tutorial. So this was week 2. On Tuesday, they will be starting week 3. So once all of this is uploaded and sort of the videos are online and such, I'll probably put a quick post in just saying that I'm participating and people can go in. Incidentally, if you have found this video through the Reddit, welcome, particularly because if you're on this Reddit, I imagine that you are probably participating yourself. So this must be a rather tedious video to watch, but I appreciate your participation anyway. And then so I was talking a little bit about some of these comments and all of that. I've been intrigued by some of the things that I've seen, but I do actually want to see what's going on with some of these FAQs. But by far, the ECS here is the one that interests me the most. I do still need to get a better idea in terms of roguelikes in general. Like, obviously, this is a community dedicated to roguelikes, and I certainly don't dislike them, but I'm very short on, roguelikes that I would say I really love. And the roguelikes I tend to love are, excuse me, are the ones that have really taken those ideas and run with them in a totally different direction, not necessarily the ones that this community is really dedicated to. Not that I think there's anything wrong with that. It's just that, I have never played the original Rogue. And sometimes when I've played something like, I think NetHack was one of them, I sort of looked at it and was like, why is there ASCII text all over the place? This doesn't make any sense. This isn't fun. So it's taking a little bit of getting used to. But tutorial like this is actually really doing a good job of sort of opening my eyes to a bigger and more interesting world. And the one last thing I'll say, I actually wanted to talk about this a little bit before. One thing that I really like about this tutorial is, let's say that you do this and you don't discover your passion for roguelikes. Like, maybe that, you're glad that you do this, but the real takeaway is that this is not for me. Like, this is not my genre, or I don't feel like I have anything to say as part of this. I think there's something really nice about this tutorial structured in a way that it takes advantage of the TCOD library, because while there's quite a bit more complexity that would be involved in terms of using something like Godot or Unity or Unreal, or we're spoiled for choice in terms of engine, so just pick your favorite. But the fact of the matter is that it's not all that different from this, right? You still need to think about how you're representing the world in data. You're taking advantage of some work that people have done ahead of you to save you from doing some tedious work. So, for instance, Bresenham's line algorithm, we didn't need to worry about how to carve out the paths between the rooms. Very similar things exist inside of Unity in terms of simplifying your life. And sometimes part of the question is just how do you become aware of these features, of these time savers? So for me, that's usually just a question of reading the fine manual. If I run into something that I don't fully understand, like say the future, take the time and read up on something like this. And I'll confess, I'm still not, I have a vague idea in terms of how this works, but I don't have like a really firm grasp in terms of exactly when I would need to call this and when I don't. I'd essentially be waiting for errors to pop up. Also doing little things like making sure that the attributes are up, or the names are up to date and things like that. But to me, these are the ways that I sort of get my toe in the water. And then when the time comes, I'm hoping through the process of asking those questions, this is how I start learning about some of the time savers. And again, the same would be, if I was reading the Unity manual or something like that. And of course, we have even more tools now which don't really require any education, right? Everywhere, or the Unreal in Fortnite, or a lot of games are really just taking, or Roblox. They're really just taking that idea of giving you the tools, and the tools are part of the game themselves. So very exciting time to be doing this stuff. Anyways, I am going to enjoy my coffee, and oh my God, it's already 5, so probably I shouldn't be enjoying this coffee, but I'm going to have it anyway. And I'm going to do something that's not sitting in front of the computer. I will be back. Probably I'll record something on Tuesday for week 3, which will be part 4 and 5. And if it's closer to part 3, I'll do them in one go. And if it's not, then I'll just split that over 2 videos like before. But either way, again, thank you for watching, and I hope to see you in the next one. Take care.